It's so great to have you guys here again on another video. We haven't done a video in a while, so I'm really excited to get started on this video. So we are doing projectile motion today, 1.11, put 1.10, this should be 1.11, page 20. So you can take a minute to pause the video and write down the question. So we're doing projectile motion, and projectile motion is literally quadratics in the real world. And projectile motion is literally anytime you throw something or project something through the air or whatever direction it's going. Throwing a pen, as you throw it up, it's gonna come down. A basketball, a soccer ball that gets kicked, a rocket ship that's launched. If you just jump in the air yourself, those are all projectile motion. And you are literally, when you do those things, creating a parabolic function, because everything that goes up into the air reaches a highest point because it has to come back down due to something called gravity. So we're going to get started in how projectile motion works and how we use it in word problems and how to solve these word problems with projectile motion. So I'm going to do this as a think aloud, and during this think aloud you are responsible for the same two things you've always been responsible for forever, and those two things are writing down my thinking question and then also writing down all of my work, evaluation steps, and anything else that is necessary for you to fully grasp this concept of projectile motion word problems. Great, let's begin. The path of vertical motion of a basketball is modeled by the equation h of t equals negative 16t squared plus 45t plus 9, where h is the height in feet and t is time in seconds. A, find the initial height of the basketball. B, how long is the ball in the air? Okay, well, I just read a lot of information, so I'm just going to break this down by using some annotation strategies. And that one is going to be cubes. So first I want to circle all my numbers here. So I see that I'm just going to circle this equation because it has all my numbers in it. That's the only place I see numbers. Now I'm going to underline my question. So I'm just going to underline, find the initial height. Find the initial height of the basketball is part A, and part B is how long is the basketball in the air. So I know I have to answer both of those questions. Now I need to box some keywords. So the path of vertical motion of a basketball is modeled by the equation h of t, where h is the height in seconds. So it's h is the height in feet, h is the height in seconds, and t is the time in seconds. So t is the time in seconds. And just to make that perfectly clear, I'm going to identify that. So h equals height and t equals time. And based on where it is in my equation, so it's h of t, that means h is my independent variable, or my dependent variable. And t is my independent variable, because it's in the equation, t, 16 times t. So I know that that means it's independent, and h is what I get on the other side of the equal sign by itself, so it's dependent. Because I can only get the answer depends on everything that's happening over here. So my first question is asking me to find the initial height of the basketball. And I'm looking at this equation, h of t equals negative 16t squared plus 45t plus 9. Based on the keywords in this question, which key feature of a quadratic function am I trying to identify? Based on the keywords in this question, what key feature of my quadratic function am I trying to identify? So the first thing I want to do is I want to identify my key function, or my key feature. Identify key feature from the question. So when I look at this question, it says find the initial height of the basketball. So I know the key word here is initial height. And when I think about the word initial height and where I've seen that before, I think about linear functions and the linear word problems I used to do in Algebra 1. And I remember from linear, initial means start. And I know that my starting value or my initial value is my y-intercept, or when x equals 0. Or in this case, when t equals 0. Because I know something's initial, the initial height is the starting, so that means my time, t, will be 0 when this starts. So I know that for part A, the initial height means I'm looking for the y-intercept. So based on the structure of this equation, I can see that it's in standard form. And I know that when my equation's in standard form, the c value determines my y-intercept. So I'm going to use that c value of 9. And that will determine my y-intercept of 0, 9. And that tells me at 0 seconds, my basketball is 9 feet. Which means, so at 0 seconds, the ball is 9 feet. So now I can use that key feature, find the key feature. So I found my key feature. And then write your solution. So yeah, 0 seconds, the ball is 9 feet, which means the initial height of the ball is 9 feet. And then we will get to part 2.